First of all, this is a presentation about building a next-generation e-commerce system. I've just played a bit with the title because I thought it's going to be more interesting. And a brief disclaimer in the beginning. This is not a talk on a particular Spring technology. I'm not going to focus on one technology, and instead I'm going to talk about lots of different technologies and how we use those technologies to implement our own platform for e-commerce, the problems that we had, the challenges that we faced, and how we managed to solve those problems. Right, so just before I start very quickly, here's a table of contents of what we're going to cover today. So I'm going to speak about, in the beginning, about the problem and why I actually decided to build an e-commerce platform. What was the problem I was trying to solve, then the solution that I came up with, and then the meat of the problem, the presentation, the core of the presentation is 60 minutes of Spring talk and the problems and the challenges I had, how I managed to solve them. And again, in the end, there will be a Q&A session for about 5 to 10 minutes. Yeah, so a little bit about me. My name is Petar Tahchiev. I'm Bulgarian. I'm a mathematician, a software developer, and an entrepreneur. I graduated mathematics from the University of Sofia, but my life turned up an unexpected turn of events, and I ended up in doing software. And about 4 or 5 years ago, I started a company called Nemesis Software because I wanted to build an e-commerce platform. I'm also an Apache Maven developer. My journey with the Apache Software Foundation started about 6 years ago. I'm also co-authored a book called JUnit in Action. It's on Amazon. It's an interesting piece of book, so if you want to check it out. I'm really interested in Spring, and I'm really interested in e-commerce. And last but not least, I'm a hobby musician. This is my SoundCloud. If you share the same passion, maybe we can talk about it later. Now, mind the gap. So why I started doing e-commerce, what was the problems with it, and basically I started with the e-commerce around 2008. I joined a company that was using one of the enterprise platforms on the market, and they would send me to different clients, and then I would implement websites using that platform. I implemented more than 30 successful e-commerce stores, ranging from huge corporations like Samsung down to really small, tiny businesses. And I noticed several patterns occurring every time you go to a client. Basically, the client would have some sort of a PHP solution set up, some sort of free solution set up. And yeah, usually this would be like a Linux, Apache, PHP, and MySQL, because that's good. They had some idea in the beginning. They wanted to test it. They wanted to go very quickly to the market. And yeah, either this idea would fail, and we would never hear about them anymore, or the idea would turn out to be good. So they had to install, they had to set up an IT department, and they had to install some open source software. And usually it all worked pretty well until they hit some critical amount of volume in terms of orders or page requests and so on and so on. So then they already had the amount of orders, so money was no longer a problem, and they wanted to migrate. Thank you. They wanted to migrate to something which was more stable. Or I remember clearly one example was when I was in Holland, we were implementing an e-commerce website for kids' clothing, for babies and little children. And the PHP solution was running perfectly fine. It was set up on 29 PHP nodes. And the client would come to me and say, it's working perfectly fine during the day. It's just, between 6 and 7 o'clock, we experience quite a lot of traffic, and then it crashes all the time. And they figured out this is because all the mothers would come back from work, and they wanted to check out the website. They wanted to see what's new. They wanted to buy some clothes for their kids, and they were experiencing quite a lot of traffic. The website would crash down. Customers were not happy, and they were tracking with Google that people are actually leaving the website and never coming back. So they contacted my company. They wanted to have an enterprise solution, and because basically they had a scaling problem, an infrastructure problem. They couldn't deploy the code immediately on all the 29 PHP nodes, and also update the database with new tables and columns and so on and so on. But they didn't have problems with resources anymore in terms of money, because they already hit the traffic and they wanted to move to something enterprising. And this was actually one side of the picture, and now the other side of the picture is where there's several key players on the market on the enterprise level, which licenses for the e-commerce platform. I'm talking about like companies like SAP, Oracle, IBM, you know. Those players would charge normally between millions of pounds, millions of dollars for their license. And, you know, they were happy to take your money, you know, because they would offer something which all of those platforms pretty much, I noticed, suffer from the same disease. They were using legacy software. I clearly remember they were using some sort of Spring 3.1, you know, stuck in a legacy software. It wasn't so easy to migrate to a new version. They had modularity issues. Basically, you would buy the whole platform. You couldn't. It was quite difficult to select several modules that you want to purchase. Again, they had infrastructure issues, like particularly for this client in Holland, we managed to drill down from 29 PHP nodes down to 9 Java application servers running in a cluster. But again, if you have to, you know, update all those nodes with the new software and install a new and update also the database, it takes a bit of time, and it wasn't something that you could do just on a breeze, like you've seen on all those Spring demos. But it wasn't just the software. They had proprietary APIs all over the place. And to learn those APIs, you need to have some sort of documentation. And their documentation was restricted. So when you get hold of the platform, first thing you have to learn it. And then, you know, you spend quite an amount of time learning it. But this actually increases the time to market, because the customers were not happy. Because yeah, everyone wants to just buy the platform and just go to production the same day. So I noticed there's some sort of a gap in between, you know, loads and loads of free open source solutions that basically you can take off the shelf and experiment, and then several key players on the market that offered some enterprise solution that wasn't cloud ready or let alone cloud native. So there seemed to be like a huge gap in between that I wanted to fill in, and that I wanted to produce something better. Like I was coming to these Spring One conferences, I was watching the Spring videos on YouTube, and I would think to myself, there must be a better way. You know, we all see how easy it is done with Cloud Foundry and with all those goodnesses that we have with Spring Boot. There must be a way to do it. So that was the whole drive and the whole idea behind me setting up my own e-commerce platform. So I started thinking more and more about it, and I came up with a solution. Well, I wanted to build an e-commerce platform right from scratch, and I wanted to build it on these 8 bullets here. Because I thought I really spent some time thinking about what was lacking in those enterprise software and what was also missing in those free solutions. So I wanted to build an enterprise platform. This means that it must be built on a language that is, well, scalable and stable enough. Like, no offense to PHP, but I'm not a fan. I wanted to focus more on the right side of the segment of the picture that I told you, not so much on the free solution, but rather build something that is stable than something that is free but not so stable. I wanted to build something that is cloud ready, and being cloud ready, you know, I read the Cloud Manifest, the 12-factor app web page. And I wanted to implement something that actually complies to all those 12 factors. And it must be, because let's all agree that, the cloud is the future, and if you're hitting performance problems like most of my clients, or like 99% of the clients that I worked for had, the only real solution to that is to actually migrate your platform to the cloud. I wanted to use latest and greatest of the open source. I wanted to make it easy for our clients to be able to upgrade to a new version of Spring, or to a new version of MySQL or whatever. You shouldn't be locked in with some old version just because it's hard to upgrade. This also has like a security impact, because if you're stuck with some old version, and there's patches coming up, and it's not so easy for you to upgrade, then you have security vulnerabilities. I wanted the platform to stand on open standards, meaning that it must be built on top of JSRs, basically. So you could easily swap in the JSR implementation and not locked in with a custom implementation or with some vendor-specific implementation. So I wanted to be able to implement anything against the JPA spec, for instance, and you would be able to use Eclipse links or Hibernate or OpenJPA or whatever you want. I wanted the platform to be modular, so that the customer would be able to buy this module and only pay for those modules, instead of like buying the whole thing and then just picking up 2 or 3 modules. I wanted all the API to be exposed via REST, because Internet of Things was just coming up, and like mobile devices were just, when I started, mobile devices were just the trend. So I wanted to allow the customers to connect to my platform via mobile or tablet or smart TV or their microwave or whatever they want. I wanted it to be easy to use, easy to import data, and fast time to market. So I wanted it to be easy to use, basically to have some sort of configuration that you can describe all your data, and then in a human readable format, preferably Excel, or text, and it should be easy to import that data, which would significantly increase the time to market. And I wanted to have a demo storefront that I can give to the clients, and they could start changing instead of building every time from scratch. So those are all the 12 bullet points that I wanted to have. And I actually started making it. Well, in the beginning, it was like a hobby, and I was actually experimenting more with Spring than just actually building it. But I always had this on the back of my head, that actually it will lead eventually to an e-commerce platform. So why I started experimenting with Spring was, well, I've done Java, and this is pretty much all I know in terms of programming languages. I've experimented a little bit with Python, but I'm not really good enough. And being in the Java world, Spring is the de facto standard in enterprise Java programming. You might not agree to that, but think about it for a while. And the de facto standard is not really something that a huge corporation writes, and then nobody, like a spec that a huge corporation writes and nobody's using it. The de facto standard is what most people are using. And just a quick survey on the market will tell you that the Spring framework is really popular, and is actually the most popular framework in the enterprise world in Java. So the Spring ecosystem provides you with a complete stack. So I didn't have to actually make several projects work together. I could actually work on my platform and not so much focus on different technologies playing well together, because I was picking up different Spring projects, and then they were made to work together. Also, I knew part of the team of Spring Framework back from the days when I was at the Apache Software Foundation, and I've met them on conferences, and I've spoken to them, and I know how knowledgeable they are. And yeah, so I basically trust those guys. And last but not least, the Pivotal is quite an innovative company, and the Spring team itself is quite innovative. Most of the time, you see some changes coming up in the Spring platform, and then a few years later they end up as a JSR spec. Now this rings a bell, and this clearly is here to show us that the Spring team innovates and is doing it quite well. So I started implementing the platform back in 2011. And I remember back then I was using Spring version 3.0.7. It was the latest release back then. I set up a Maven-based project, and I started playing with JPA, and I chose Hibernate for my default JPA implementation. And I wrote some CSV files with catalog synchronizations because I wanted to have a platform that supports multiple catalogs per site, multiple websites, multiple currencies, and multiple languages. So I chose CSV import files so I could, because they're human readable. You could basically throw that CSV into let's see, you can throw that CSV to your manager, and you can tell them so here's an example of one of the CSVs, and tell them fill it with your data. So you start with insert update, or delete, or whatever you want to do with that CSV. Then the entity that you want to modify, basically. And then it's a comma separated. You just specify the attributes that you want to update. And then on the next level, you just provide the values. So this was pretty nice and pretty sweet. However, the ecosystem back in 2011 wasn't complete. So for the first point was that it was missing the Spring Platform BOM. And the Spring Platform BOM is actually a POM XML in Maven that you can actually declare as a parent to your project, and then it handles all the dependency versions. So because there was no Spring Platform BOM, I had to actually manage the dependency versions myself, which was a big task because every time I wanted to upgrade a particular Spring or no Spring dependency, I had to run a set of tests to see that everything still works and everything is still intact. So this took quite a lot of my development time, but yeah, that's how it was done back then. There wasn't Spring Data Solr, Elasticsearch, REST, or Redis. Actually, it was the only thing that was out was just Spring Data JPA. And Spring Data JPA was actually what made me curious about Spring, because I couldn't believe something could be so simple and yet so powerful, like declaring an interface with no implementation and just resolve the queries from the method names. It just blew my mind the first time I saw it. There wasn't Spring Mobile, so if I wanted to support multiple devices, like I told you in the beginning, I wanted to support multiple devices, I had to implement something on my own. There wasn't Spring Session, so this meant that if I wanted to put it on a cloud, I had to do some load balancing and sticky sessions, and it was really nasty in the beginning. There wasn't JCache back then, so I had to have several modules for EHCache or for Hazelcast. So what was it? It was a Spring Web MVC project. It was using Spring Security, of course, although the Spring Security configuration was XML-based. It was using Spring Data JPA was just out, so I was using the repositories of Spring Data JPA. Spring Social was just out, so I was playing with social logins like login via Facebook and login via Twitter. I had a custom Spring Mobile implementation where I was using a handler interceptors post view. So this method is called immediately after the controller, I think, and then I just check the user agent of the request. If it's coming from a mobile device, then prefix it with mobile. If it's coming from a tablet, prefix it with tablet. But I had to maintain this by myself. I made a custom boot implementation, which was a huge effort back then. So all my configuration classes had a list of beans. And in those beans, I was manually checking, if this property is set, then return an instance of this bean. But if it's not set, then try to load this class from the class path. And if it's on the class path, return this bin. But if it's not, if it throws with no class def found, return that bin. So it was horrible. Like all my configuration classes were like thousands of lines long. But yeah, I had to do it if I wanted to provide some sort of modularity. I had a custom REST implementation that only supported JSON. I had a REST controller with response body, and basically you would communicate with that controller. And again, it was hard to maintain. And I had Maven Jetty plugin and Maven Tomcat plugin because I wanted to support both Maven and Jetty and Tomcat. And still, I was using some XML-based configurations, so it wasn't nice. So what happened really, and how did this whole thing evolved? Well, first, Spring released the Spring Platform BOM. Well, the Spring Platform BOM, as I told you, is actually a POM XML. I think I can show it to you here. Yeah, it's a POM XML that you actually can declare it as a parent to your. Do you see it? Let me just. Is it better now? It's a POM XML that you can declare as a parent to your project, and then it actually handles all the dependencies. And it turned out to be quite nice. I no longer had to run those tests and to see if anything is broken, because Spring was doing that for me. And then I created my own BOM, which is right here, because I also had several dependencies on some other projects which Spring were not using. But it was a lot better because I no longer had to maintain thousands of dependencies, but instead like 50 or 60. So to create my own BOM, I just added the version properties. And then I have a dependency management section where I just declare the dependency like this. And then I can use it just by group and artifact later on, because it was declared in the dependency management section. I also had several profiles for running some Selenium tests with Firefox and some others. But yeah, this was a nice step forward. Yeah, it provided me with easy dependency management. I added my Maven plugin declarations, my Maven profile declarations, and still there's some stuff to be improved, and I'm still in contact with the guys that are creating the BOM. Like for instance, they don't have the versions of the Maven plugin versions as a property. So if you have to override the Maven plugin version, you would have to redeclare the whole plugin, which is kind of inconvenient. But this is a really nice step forward. So what happened next is that Spring released the Spring Boot framework. So I first saw it and I thought to myself, this is never going to work out. You know, I have like literally 40 to 50 different modules, and I tried to provide configuration for each one, and it was like really complicated and long configuration classes. But nevertheless, I gave it a try, and it turned out to be really good. And you know what? Well, basically because the Spring team knows their stuff a lot better than I do. I do know their stuff. So yeah, they created some custom annotations that I used, so I could finally get rid of my construction, the if constructions. I replaced them with conditional annotations. I separated each of my Maven modules into a separate module and extracted some custom logic in that separate module. And next step would be actually, like for instance, let me see. So this is a platform. If I go to the modules, like if you open one module, so inside the SRC main resources, you have this folder metainf that ends up on the top of the jar file, and in there you specify the Spring Factories file. I hope you can all see it. Where you can basically declare where your auto configuration is. And then immediately what this gives you is that if you put that module on the class path, Spring will actually detect it and put it in the parent application context. So each of my modules, like 40 or 45 modules that I have here, are actually Spring Boot modules that have this enable auto configuration in their Spring Factories file. So now what the client is going to do is like, let me see. So now the client, what they're going to do is like, this is the client, this is on the client side. They would actually have a POM XML, and they would list as a dependency each of the modules that they wanted to use. which was pretty sweet. Like immediately you get some modularity out of the box. And this wasn't just it. You know, with the Spring Boot, it came a lot of good stuff that I didn't actually implement when I started, like the actuator endpoints, or the SSH login, or the Maven plugin. I could get rid, finally, of my XML configurations in my POM XMLs for the Maven plugins. So the overall code reduction, I'm not quite sure about this number. I made a diff in Git, but it was just too much. So at some point, I just stopped. Looking into it. But it was about 60%, including the Java configuration and the XML configuration that I was able to get rid of when I migrated to boot. But you know, open source to me is not just having something and using it and playing around with it. You know, back from the days when I was with the Apache Software Foundation, I've always tried to actually come back with something, like could be a documentation or a pull request. So this is actually what we did here. We raised more than like 11 issues for the past 1 year. We contributed the JCache actuator endpoint. So now I think it's included in the latest it will be included in the latest 1.3 release. So in Spring Boot, you have the metrics actuator endpoint. So if you go to /metrics, and then you can see on your cache, how many hits do you have? How many misses do you have? And I think they're also included on a particular region. So if you have different regions in your cache, you can see how many hits this cache has. Actually, my pull request also included a delete request. So if you make a delete request to this cache region, it would actually delete the cache. They actually didn't like this so much, so I think they're not including that. But nevertheless, we also contributed the stomp logging actuator endpoint. There's a pull request that we created. The stomp logging actuator endpoint is actually an endpoint, an actuator endpoint that you can connect with a WebSocket, and it will actually tell you the log, the log4j or the logback or whatever logging implementation you have. It will tell you in your browser or whatever you are, what's happening real time in the log. So I think I can, actually I can demonstrate this to you now. Let's see. Because I don't think it's going to be included in 1.3. The pull request is still open. I'm not sure if they're looking into it, but right, so we wrote a bunch of JavaScript endpoints, JavaScript backend consoles that you can connect with REST to the platform and basically administer it, like create new product, create new price, etc. So Jet is now started. So let's see. If I go to localhost/admin and I log in. Is it? Okay. So I think it's coming. So now this whole thing connects with a website called solaropRel.com. And you see here, let me zoom in. So I'm not sure you see it. This here is actually a portlet that connects, and nothing here is happening, but if I come here and refresh the page, we should be able to see some log. So how this thing works is that this portlet connects with a WebSocket, as I told you, to the actuator endpoint of boot, and it will actually tell you what's happening in the log. I think I can show you some of the. So here's the stomp MVC endpoint outer configuration class, and here's where we create the stomp MVC endpoint. And basically, as I told you, it's an MVC endpoint of boot. You can play around with the pull request, and if you're curious enough, and also vote for it, because I'm not sure those guys are looking into it and they will include it. So I think it's a pretty neat solution and pretty nice to have it in Spring Boot. Let's see. How much time do we have? Right. Really kudos to Stefan, Nicole, and Dave Sire, who helped me quite a lot with all my questions that I had. because they were also always responsive to on the Gitter channel, you know, answering my questions, however stupid they were. And yeah, thanks to these guys, they're really great. Also, the Spring Boot, you know, you all know that start.spring.io website where you can boot your Spring project. And this is something that we wanted to have in our company because we wanted to save the time for the customers to be of, you know, how to create a project and so on and so on. We wanted to increase the time to market. So we came up with this start.nemesis.io, which is right here. So because our platform actually is a Maven archetype, so what you do is like you fill in some details here, and company, and then on the right side, this is a Maven archetype command that actually changes real time. So you copy that, and you go to an empty folder. Like, let's see, this is not an empty folder, right? And you paste it, and hopefully this will download. The project, extract it, and create a demo project here in the demo folder. This is actually coming back to the beginning of the slides where I told you that I wanted to have a sample store that I give to the customer, and the customer is able to modify it instead of starting from scratch. So I'm not sure why it takes so long. It could be the network. But yeah, there it is. So 32 seconds. So you go in there, and you actually have core. Core is where you put the repositories and your data model. The facade is a facade layer that converts your data model to POJOs and to lightweight objects that we later on pass to the storefront where your controllers are. So let me just quickly build it. And yeah, back to the slides. So this thing is there. It's easy to use. It's fun to play with. And again, we got inspired by Spring Boot. So good for those guys. Spring Data. Right. So like I told you in the beginning, we were using Spring Data JPA, and it was great. It was awesome. But we had several problems that we couldn't solve, like particularly if you want to create a modular a modular platform like we wanted to have. Okay, how do you? So do you see this there? So like for instance, we wanted to have several modules. Say the first one is the platform, the core of the platform, which defines a JPA entity called site model. And this JPA entity has an attribute called name. And then we have another module called CMS module, which defines another JPA entity called CMS site model. And it has an attribute called theme. And then we have another module called commerce, which defines commerce site model, which has a attribute default currency. So what we wanted to have is when the client picks two of these modules, say the platform and the CMS, then he would only get a site model with name and theme. But if he picks all those three, he would get like a site model with name, theme, and default currency. So this is something not supported by JPA out of the box. So we had to come up with something unusual. So to set up this modular domain model, we came up with a solution that actually puts the JPA, that creates the JPA entities as interfaces. So this thing is now built, 1 minute and 1 second. So let me go back to Eclipse. So I'm going to open now the site model definition. So we have these definition classes, which are actually an interface. And we have a custom definition annotation, which actually specifies the name of the JPA entity and some custom attributes just for us. So it extends abstract entity model and abstract descriptionable entity model definition that gives it some more attributes. But yeah, you have here a get name method and a set name method, which are of course abstract because we're in an interface. And you put all of your JPA annotations on top of it. And then you have CMS, site model definition, which is pretty much the same. It's just here you have definition, site model definition. So it's actually telling you which definition you're actually going to enrich in the end. So we add the extra attributes here, like many2, also the annotations on the get method. Same with the commerce site model definition. You have here's a default currency, our default currency, and then when the client puts those modules in the class path, here's what happens. So you go into, where's the demo? Oh, wait a second. Demo, yeah. So it goes to core, target, generated sources. So we pretty much generate model, CMS, site model. We generate the site model on the client side before the compilation happens. So this is a generated class, as you can see from the Java doc. It looks not as nice as you would want, but it works like magic, just like Dave Sire says. So you have, if you search for default currency, yeah, there it is. So if you exclude the commerce module from the class path, it will not detect because it basically detects all the definitions in your class path. It will not detect the definition in the class path, and it will not include the commerce attributes here. So it works pretty well until you start playing with Spring Data JPA. Like Spring Data JPA, provides you with interfaces, and those repositories are interfaces with no implementation. And let's get back to the IntelliJ idea. Like if I open the site model repository, site repository. So we have created a base entity repository, but nevertheless, you have here some generics, and what Spring Data JPA does not allow is to have here an interface. You can only have a concrete class. So to overcome this, 1 second. Right, these were the implications on the modularity, and to overcome this, I basically it was something I couldn't think of how to implement, to be honest. So I took the plane and I went to Dresden to meet with Oliver Gierke. We went out for a coffee, and I was expecting him to say that this is bullshit, you shouldn't do that, But he was quite open about it, and he said that this is a great idea. Why not just support it? So we had a brief brainstorming in the afternoon, and what he came up with is a really neat solution. So platform core config. So here, this enable JPA repositories annotation from Spring Data JPA, right? It has an extra attribute that most of you are probably not aware because you don't have to use it every day. But the repository factory bean class will actually allow you to specify a custom repository factory bean. And we created one basically with the only intention you don't see it here, but with the only intention to return our custom Nemesis JPA repository factory. So in our Nemesis JPA repository factory, we extend the JPA repository factory from Spring Data, and we override one method only, the one that returns the repository metadata. Because the repository metadata is what stores actually the relations between your class and the entity name and the repository. So if you have access to that, you can actually tell the repository not to use the class, but actually to use a certain entity. So we have two attributes on the repository metadata, and we are actually populating them in a constructor. So we have this find domain class static method at the bottom, and what we're actually doing is we're taking all the entities from the meta model of the JPA, and we're actually iterating over those entities. And if it happens that, well, the domain class annotation, the domain class here is actually is a wrong name because it's an interface. So if the domain interface, you get the annotation. If the name matches the name on the generated entity, you just return it. And here in this case, it's going to be a concrete class. So this solves the problem with the Spring Data JPA both and Spring Data REST too. So yeah, to expose all the repositories via REST, we basically, let me go back to Eclipse, site repository. So the only thing to add here is the repository REST resource annotation. And then bam, we had a REST layer, which I wasn't actually going to maintain. First, I wasn't going to maintain, so I could delete my custom REST layer, which was, yeah, pretty basic. It didn't have any of the goodies that Spring Data provides, in Spring Data, if you pass last modified date header, it's going to show you if it was modified or not. My REST layer did not provide that. So migrating to Spring Data REST had a lot of benefits for us. But we didn't stop just there. We raised more than 30 issues in their Jira because we were heavily testing the Spring Data REST, primarily because we had these JavaScript backends that the customers would use to create new products and so on. And the whole communication happened via REST. So if it so happened that the REST is broken, or if we update to a new version of Spring Data REST and something gets broken, all of our backend JavaScript consoles would stop working. So that was the whole drive behind it. So Spring Data search. So we wanted to provide some search functionality on our website, on our sample store application. So I started actually playing around with Solar, but in the initial implementation of back in 2011 of my platform, I had to have Solar running on a separate port, and then I had to connect, and I had lots and lots of custom code. Well, with Spring Data, when Spring Data announced the Spring Data Solar and Spring Data Elasticsearch, it was actually great news for me because now I could use, I could have separate modules for Solar and Elasticsearch and provide just the repositories which had the same signature. So if I go now to the search request product data. So basically I create here a search request product data that I'm going to populate with some details, and then I'm going to save it in the Solar index by calling the repository.save. And then if I look into the classes that extend this class, I have Elasticsearch request product data and Solar search request product data, and pretty much down there I just make it fancy, for Solar to like it, basically. And then in those two modules, I have the request data and also the repository. So it was quite convenient and quite easy to do it. The whole migration happened in less than a week. So Christoph Strobel helped a lot with by answering my questions and giving some ideas. About Spring Data REST, like I told you, we wanted to have this REST layer so all the backend administrative interfaces could communicate with the platform. Unfortunately, we had to make it better because, let me show you real quick. Right, this is our backend console. This is the console that we use to create new products and to create new prices, and etc. Let's go here. Backend. Woo, that's big. I'm just probably gonna make it smaller. Yeah. Okay, so here on the left side we have all the entities that are defined in the database, right? So if I open initialization, we get no, actually, if I open CMS, we have the site, the one site that we saw before. So to search on it, we have this field here, UID, right? This all happened really nice because, like, if I go now to the REST layer, which I have to, sorry about that. So if I go now to the REST layer, and you can see here, here's all the entities that are defined in the database, and all of those that have a repository actually. Right? If I open the site, there's a bunch of, if I go to search, there's a bunch of actually methods that you could call. And so that it happens that they're really nice templated, so we can actually say UID is not null, is starting with, contains, blah, blah, blah. So we can read those method names and actually parse them and construct this really nice search field here down there. And then here you can you see also the results that come from the search. So it all happened to work pretty well with Spring Data REST. The problem here happens is if you want to have, let's go to a product. So like for instance, the product does not expose here the catalog version, as you can see. So, and the catalog version, so let me go to commerce, catalog, product. Right, so it doesn't expose the catalog version. You will see it's a link. If I search for it, you see it's a link to another resource. Now, how do I expose it here? And not just that I expose it here, but I actually combine two fields, because the ID of the catalog version, if I go to catalog and search for catalog version, we have the ID of the catalog version is just stage or online. Basically, the combination of catalog and catalog version is what is unique for this entity. So here it was an interesting challenge how to expose this, and the way we solved it is by actually adding a projection equals search, and now if you search for catalog version, you see that it actually returns it once you add the projection. So the way it's done is we have product search, product model definition, search projection, and you just pretty much add an annotation, add projection. You name it, you give it a name, and then you can give it, you can tell which type does it actually comply to. And this one extends from abstract entity. So this is basically the method name that you define is actually what is going to be returned. So if you skip some of the properties, they're not going to be returned in the end. So in the abstract entity model projection, we specify we want to have when we say the search projection, we want to have the UID, the PK, and the entity name. The nameable says that we want to have the name and, what happened? Oh, shit. Sorry, I'm going to exit the presentation mode real quick. What was it? Product, search, projection. So the catalogable entity model projection basically that defines how things should be returned. And it says, give me the target, the catalog version, the catalog ID, and then the target catalog version ID. So this is how the magic happens to return different JSON. And we have a validation. This allows you to also, Spring Data REST provides you to have validation so that when you submit your form, you can have some validation and so on and so on. Now, Spring Session. Before I continue, let me kill this. Let me kill this. So before I continue, I'm going to have to initialize my database because I want to show you my demo store in the end, and it normally takes 3 to 4 minutes. So I'm going to initialize my data with the CSVs that I showed you. So this is the data. I have all the data in these CSVs. So to initialize the data, we have a custom Maven plugin that you actually invoke. And I'm just going to let it go in the end, in the background. When Spring Session came out, it actually solved our problem about running our platform on a cloud, because our pre-Spring Session implementation actually did not use any Redis underneath, so it was actually attaching the session to a cookie. So if you wanted to make sure that basically we had the problem that customer would add something to the basket, and then the second time they hit our application, it will be redirected to another node, and the session will not be there, so the product will be gone. So to solve this, we had some sticky session magic, but yeah, it wasn't good. So replacing our Spring Session implementation, or replacing our session implementation with Spring Session turned out to be extremely easy. So what we have done is we created a session service. Session service. Oh, wait. Enter presentation mode. Right, so we have a session service that says, that has a method get current session. And now there's a problem with this session service, not so much a problem, but this session service is actually very near the database. So it's very near to the repositories and data models and our services. So we can actually have services like user service, give me the current session, and then it will actually call the session service and find the current user, or give me the current site the user is browsing. So because we have multiple websites, the user could be browsing different sites at different moments. So we had to put this in our service layer, but Spring Session only works near the presentation layer, because it's pretty much a filter that you declare. And the way we did it before, we had to pass here the HTTP servlet request down to the database layer, which was kind of nasty. But the way we do it now is actually we take the request attributes from the thread local request context holder. And if it's, well, there are actually two scenarios. If they're going to be null, or if they're not going to be null. Like if they're null, then we might be running in a cron job, which we check here. And if we're not, then actually we throw an exception that you cannot use it outside of a web request or a job. If they're not null, we actually search for the current session in the request attributes, right? And if it's null, then we create a new session and set it in the request attributes, so that the next time you come back to the service, it will actually take it from there. This works pretty well. And again, Rob Winch came up with some of the ideas about this, and we actually had some problems with multiple cookie sessions, but I don't think I have. Yeah, I can. So cookie. Okay, I don't think I can find it now. Okay, moving on. So Spring Batch. Spring Batch allowed us, gave us the possibility to orchestrate our jobs. So in every website or in every application, you want to have some logic that executes, independent from the user. So in our case, our requirement was actually to have someone generate the sitemap XML at midnight, or download currency conversion rates at midnight. So we had to have some sort of cron jobs that execute daily or on a specific period of time. So we decided to go with Spring Batch primarily because it's in an implementation of the JSR 352, I think, spec. So the initialization is complete, and I can walk you through the log very quickly. So the initialization process is a process that will actually do several things. First of all, it's going to delete your existing database. It's going to drop all the tables. Then, like this line here, then it's going to migrate your database to the latest or to the version that it has in the class path. Like in this case, it's 0.6. It applies the migration. The migration is actually using FlyWayDB to create all the tables with all the foreign keys and prepare the state of the database the way it should be. And then it's going to launch jobs. So these are Spring Batch jobs that actually are launched with different parameters. And the parameter being the CSV file that we want to import. And it's going to launch 42 of these CSV files up until they're all imported. And now when it's done, because it imports only in the offline catalog, a synchronization is going to kick in, and we are actually again using a Spring Batch to run jobs to synchronize the catalog between the staged and online. The synchronization is pretty much a process that copies all your changes from the staged or the offline catalog into the online. And once that is done, we have 2 more CSVs to import, and it's pretty much finished. So I'm going to start now the, it takes about 3 minutes and 20 seconds to finish. So I'm going to boot now my application, and when it's done, in the meantime, I will continue with this. With Spring Batch, we had several problems. Now, the first problem was that we couldn't use chunks. Now, the chunk in Spring Batch is pretty much a term that defines how many of the items are you going to read before you pass it to the item processor, and in terms, then he will pass them to the item writer. So we couldn't use chunks because, as you can see, our CSVs have this strange, not strange, but have this layout. So you have some data, some header, then some data, and then you have a blank line. And then you have, again, some header, some data, and some blank line. So we had to implement our own basically dynamic chunk. So what we do is we reread all the data up until the point we find a blank line, and then that's our chunk. We pass the whole data that was read to the item processor, and then the item processor is gonna process it, and it's gonna give it to the item writer. So the way it is implemented is using an aggregate item reader. So the aggregate item reader implements item reader, and it pretty much says there's a holder that holds all the records that you read up until it is exhausted or it's empty. And we also had another, this is actually very close to a Spring Batch example they had on GitHub. So you can have a look at that example and see. But we also wanted to read those CSV files in a multi-threaded environment, because we realized if you're having several cores on your platform, several CPU cores on your platform, you're not actually taking full potential of your platform, of your computer. So what we did is so we have here a task executor that is included in the aggregate item reader, and this task executor is actually, we create a runnable for the holder to read the records, and then we add the runnable to the task executor. And the task executor is created with a property. So if I open my application properties and search for worker, so we have this property that specifies how many threads do you want to execute the reader within. Right, so again, kudos to Michael Manila, who also made some suggestions on the session implications that we had. We wanted to wait 1 second. We wanted to be able to have some sort of a session when you run your job in. So you could specify, okay, I'm going to run this job in a with a user, admin and with a currency, US dollars, etc. So you could add some parameters, and then during the execution of the job, you could read those parameters and have some values for them. So in the session service, get current session, we have this piece of code here that says, well, we take the job context of the job synchronization manager. So it's pretty much checking if you're running in a job now, and it says if the job context is no, you're not running in a context. But if it's not, then it tries to find a current session from the job context with this attribute. And the way so CSV platform code CSV import config is where we configure our aggregate item reader. And second. And the way you do it basically is you have to specify the session service on the job. I just don't see it here. I guess I must have missed it. Okay, let's try and move on. Well, the Spring Web MVC we're using pretty much out of the box. The little bits and pieces that we have added is the Java implementation. How many of you know what Java is? Wow, I wasn't expecting that. So Java is a tool hosted on java.net that allows you to minify and compress your basically your resources like CSS or JavaScript. But it's a bit more than that. It has a really nice configuration because you specify the configuration in property files. So if you want to have, let me see, we have our theme here. Let me see. Right, so we wanted to give the possibility for the client to create different themes and look and feels that he can different themes that he can drop in and replace the look and feel of their website. So the way we did it is we actually specify the theme as a web jar. And the web jar is basically a jar that holds not only some classes, but also in the meta-inf folder meta-inf/resources, it also holds some static resources like CSS and JavaScript or images if you want. And yeah, in this particular web jar, we also have some Spring configuration and create a bean of type theme resource bundle processor. And then we can say for the normal view of the of the theme, you're going to use these jQuery tools, jQuery libraries, and for the mobile, you're going to use those, and so on and so on. So it's pretty nifty. You're now able to create several different themes with their configurations. Now, how do you find? You can the way when you specify the library, it's actually going to construct a URL out of the ID that you provide, and out of the ID that you provide, and also the version that you provide. The version comes from this file called webjar-versions.properties, and you basically specify the ID of the library / and some funky expression that actually Maven is going to replace. Like if I search for this jQuery WebJar version, it's going to find it here. So it's a Maven property that actually will be replaced later on in this class before it's packaged. So this way you can pass the version of the WebJar to the theme configuration. Ross and Tahchiev also gave us some great ideas on the web MVC, so I'd like to give some gratitude to him. Spring security. Well, on our website, we had to secure the storefront, and let me see if it's now running. Yeah, the demo application has now started, so I can show you a bit of what it looks like. Solo local. So solo.local is a hosts entry in my etc hosts file. So this is basically the demo store that we are giving to the customers, and they can play with it. But we have we wanted to have several login endpoints. So /login is one of them, but we also wanted to have /checkout login. Yeah, this one also allows you. This one also allows you to just proceed to checkout by not just logging, but as a guest. So these are two completely separate login forms and login screens. So the way we do this is right. So the storefront. Right. So we have our storefront security config, which of course extends web security configure adapter, and then inside we basically create two static classes, one for checkout here, which again extends web security config adapter, and another one for default storefront security config adapter. And then we have different ant matcher patterns. So one is on /checkout, whatever, and then the other one is on basically anything. We also have down at the bottom, we have created access denied handlers, because we want to handle the different ways the access is denied. And I think success denied handler, no, authentication failure handlers too. So yeah, the one will redirect you to 403. Actually, the other one will probably do the same. Another challenge was to actually secure the REST, because exposing the REST to, having a REST is great, but exposing it to the whole world is not a great idea. So the way we did this is so we have this REST services security configuration, which again extends web security configure adapter. And the configure method is what happens, what does the whole magic. So, well, first of all, we check if we have the project debug property set. And if it's true, we just permit all. If it's not, then we say that the authentication can happen here, and everyone is allowed to try to authenticate. But everything else must be, you need to have admin group role to secure it. And then we also, on top of that, say that we enable the HTTP basic authentication. This means that if you go to, because during development time, it's quite, it's a question? Sorry? Yeah, well, the headers, I can't really say why the headers are disabled, but the CSRF is disabled because we're doing some strange stuff with JavaScript by posting to different domains. But I just saw the talk of Rob Winch today, and the way he exposes he creates the CSRF endpoint, the way that you can get the. So we're gonna change that in the future. Thanks. Right. So we created an HTTP basic authentication. So if you don't provide, and we also have a custom filter. So the custom filter goes here, and it's created here, REST authentication filter. So our REST authentication filter is going to get some values from the headers and say like a username and expiry token. It's going to create some salt or some hash. It's going to try to match it, and if it matches, it's going to let you go through. If it doesn't, then it's going to fall back to HTTP basic, like the way you saw over there. So, and then you can try with HTTP basic, and if you don't, then it's just basically say it's forbidden. This here is done primarily because during development time, we want to have better experience, and it's quite tedious for us to just include headers or parameter names and etc. Right, moving on. Yeah, Rob Winch here, great guy. He knows quite a lot. Spring Mobile. Like I'm coming here near the end, but I have plenty of time. So the way Spring Mobile worked in the beginning, I told you, was with quite a lot of hacks because and the problems that we had with Spring Mobile is that we wanted to support with one platform, we wanted to support multiple websites. Like some of those websites would be responsive, and some of them would have dedicated view, say another set of JSPs for mobile and tablet and so on. And this just, I could like basically demonstrate it to you right now, like on my local machine. If I, like this website now here is not responsive. If I switch to, let's see, no, not this one. If I switch to iPhone, and quite conveniently, I probably have to be in a incognito window. Right, so it loads some JavaScript is missing, but you can see it's another set of JSPs. So, but here we have another website which is purely CMS driven, and this one is responsive in fact. So if we scroll down here, you can see, well, it becomes responsive. Like, there's not much to see here, but how do you do that? Like, because if you the moment you declare a device view resolver, this is going to be used everywhere. So even if you open the responsive website, it's going to render you another set of JSPs which don't really match the CSS, so it looks ugly, and so on and so on. So the way we have done it is we have created our device view. Now, actually, before that, the way we've done it is we have added a new property on our site model. So our site model definition name has now a new property called isResponsive. So we add that, we build the platform, and then site model now has isResponsive. Right, so the isResponsive is here. Then we have to change the data to add this column, this Boolean column there, and then we can basically say true or false for both. And now back to the code, we have this device view, current site device delegating view resolver, which will override the light device delegating view resolver and override the method get device new view name internal. So in the end, what we do is we actually check if the site service, give me the current site the user is viewing. And if it is responsive, then return the normal prefix plus view name plus normal suffix. If it's not, then just delegate to the parent. And yeah, as you can see, this works pretty well. What else? I think I have some more slides. Testing. Well, testing is also a part of the development process. And Spring helped us there too. So now each of our modules is actually a separate Spring Boot module. So it has a set of unit tests and integration tests. Unit tests are executed on during the build. Integration tests are executed when you push, and Circle CI is going to execute those. The REST module, however, also has some mock MVC tests, and I can show you, let me see, unit HTTP REST integration. So we have a bunch of whatever the JPA entity name, then HTTP REST integration tests. And all of those extend from abstract REST CRUD integration test, which is a test that we have written. And in there you always have a get all, get one, save existing, create new, or remove. So each of those will delegate to the parent, and in the parent you call get mock MVC and perform some like operation, and then you say specify some media type or a content type, and then you assert some expectations. And it's not just that, we have also specified the document method here coming from Spring Data REST docs. So this will actually generate some REST documentation for you, which is pretty great. Then the storefront also has these mock MVC tests, but it also has a bunch of Selenium tests. And we have created 2 Maven profiles, one for Firefox and one for Phantom.js, which those Selenium tests always get executed on Circle CI during push. Well, on the documentation side, we basically saw how Spring are doing their documentation. We felt it's a great way, and we went a bit further, I think. Well, our documentation is stored in the Git repository right next to the source code. It's actually generated as a Maven site, and it's written again in the ASCII doc format, just like Spring. It's built and deployed on every Circle CI push. So I can show you a bit. Actually, not this one. Current platform. So, all right, I probably have to go from here. So you go on the website, you click on docs, and then this is all deployed during every Circle CI push, and you can see changes to the documentation like immediately and so on. And getting started, yeah. And changes, when you change, what's even great is that these XML snippets and Java snippets are actually included from the source code. So the minute you change the source code, the minute the documentation is changed. So it works pretty great. Just a few lessons learned in the end. You know, we've been building this platform for about 3.5, maybe 4 years now. And well, first lesson is that software is never complete. And basically, you can never get it to a level that you're satisfied with. There's always room for improvement, but you know, this is the way it is. And when I started building it, you know, 4 years ago, I thought it's a pretty nice solution. Nowadays, I also think it's a pretty nice solution, but I think that the old solution was pretty crap. Maybe in 5 years, I will think that, you know, this now that we have has a lot of room to improve. You never know. Again, looking back, I think Spring was the right choice for us. It has given us quite a lot. When you have a question, don't hesitate to ask for support. Sometimes, you know, the more you question you think it is, the more value it can bring. And also, the Spring team is really great, so they always answer and help you. Any questions? I think I'm about 10 minutes. I have 10 minutes for questions. Oh, there in the end. Sorry? You're browsing the website? The user manual under the docs. Docs. User. Sorry, user manual. Sorry? Platform. User manual. Yeah, well, it's some of the links are missing. Yeah, I don't know. This is a Cloudflare that is there. It's a good catch. Yeah, yeah. We're clearly behind schedule on the documentation, but yeah, it's a good catch. Thank you. Yeah, you in the end. Do you want to know more about Spring Data projections? Oh, okay. Right, so product search, product model definition projection. Well, it's right. So you can define a number of projections if you want. Like in this case, I have defined only one, search, called search, right, with this name, and then. Well, you have to specify what sort of attributes you want when you call this projection, what sort of attributes to be returned, right? So the way you do it is you create an interface, and in there you have to specify then the getter and the getter names of the attributes that you want, like get description. So now when I call projection equals search on the product, it's going to return description, but nothing like if I would put only description, it would only return description. If I wouldn't put nothing, yeah, that's it. That's pretty much it. It's does that answer your question, or? Oh, it's part of Spring Data. Yeah, it's there. It's in the documentation, I think. Yeah. Anyone else? No. Yeah, you have. Oh, sorry. Yeah. Well, okay, let me go. This is the demo that we just created. Inside Storefront and Target, there is a WAR file. So the application is 173 megabytes, and it's a Spring Boot app. So right now, when we started it, it took 80 seconds because it starts embedded Solr and embedded Redis for the Spring session and embedded Hazelcast for the distributed cache. But if you go to a Cloud Foundry, you basically have to specify these as services. So it should be a lot easier. We have tested it on Heroku, not on Cloud Foundry, but our plans are also to create like an image and to put it on Cloud Foundry and have it available there too. Yeah, shouldn't be hard, I think. Yeah, well, this is clearly not a microservice. I would argue it's not really also a monolith. Like, and again, I don't think microservices are. I don't think everything should be a microservice, to be honest. But maybe at some point we will extract some of these modules that you list as a dependencies as a microservice. Not all of them though. I don't think that microservices is just. It's not a silver bullet. It's not there to solve all your problems. This one works pretty well right now, and I think it's a good architecturally. I think it's okay. You had a question, I think. Sorry. Again? Storing sessions in cookies was a trouble for you. Storing session in cookies. Oh no, because right. Yes. So let me show you real quick. This is our CMS platform. So we wanted to have a CMS platform where you can edit your content, not the products, but particularly the content, like banners, images, and etc. So now that this one is running, you can go here and log in. Come on. Right, so when you log in, you will see that on the right side, you see the website, right? And I'm logged in as an admin, but this website here is viewed as anonymous. So we had to somehow separate those. And the way we did it is basically storing 2 cookies for the session. One for the user that is logged in the admin as an admin right now, and the other for the session of the user on the website. So this was a bit of a challenge, but it's basically declaring 2 cookie strategies. I had it here somewhere. I just can't find it. Maybe we can talk about it later. Yes. Yeah. Anyone else? No? Okay. I have a bunch of stickers for your laptops or some T-shirts. Feel free to come by and pick some after the talk. Yeah. Thank you.